In the previous section, we have studied spherical mirror, and the pole is usually represented by P. Till here we studied in previous video. Now we are moving to next. The reflecting surface of a spherical mirror forms a part of sphere. If any mirror in the shape of curved, then the totally it will be circular shape. It is a part of sphere. They are representing that it is a part of sphere. This sphere has center. Here you can see that if any mirror, I will show, imagine that this is a mirror, curved mirror. It is a part of circle or sphere. Totally it is enclosed by one sphere. Here to draw the sphere we need one center, that is known as this sphere has a center. This is called C. Center it is called C. This point is called the center of curvature of the spherical mirror. This point what we are seeing here, no, this is called center of curvature. I will show with the small diagram. If you draw like this, where you have drawn from this one, that point is called center of curvature. This is center of curvature. It is represented by the letter capital letter C. Please note that the center of curvature is not a part of the mirror. We have to be careful, that is center of curvature is not a part of mirror. In the mirror it is not a part, it is a, without the center we can't draw the sphere, so it needed, we can tell that it is having some distance. It is a part of mirror. It lies outside its reflecting surface. It is lying outside. In the concave also, convex mirror also, it is lying outside. The center of curvature of a concave mirror lies in front of it. In concave mirror, in front of the mirror, we can see. Imagine that it is a concave mirror. Once again, I will show with the diagram. Concave mirror means this is concave mirror. In front of that, we will get the center of curvature. In the convex mirror, we will get behind or back side of the mirror. The center of curvature of a concave mirror lies in front of it. It is important. In concave mirror, it lies in front of it. Which one lies? Center of curvature, the C, that lies on in front of the concave mirror. However, it lies behind the mirror. When behind the mirror, in case of convex mirror. You may note this in figure 9.2 A and B. Some diagram is given below. In that one you can observe these things. The radius of the sphere of which the reflecting surface of a spherical mirror forms a part is called radius of curvature of the mirror. I will show. This is a mirror. Imagine that this is a mirror, concave mirror. Here center of the curvature is present. From here to here the distance is called radius. This is represented as called the radius of the curvature of the mirror. We will tell that it is a radius of curvature of the mirror. For this mirror, it is the radius from the center to the pole. At the center of the mirror, it is called radius of curvature. It is represented by the letter R. It is represented by the letter R. In the convex mirror also, from the center it is represented by R. This is P, pole. You may note that the distance PC is equal to the radius of curvature. Here it is important. P and C. P means pole, C means center of curvature. It is equals to the radius of the curvature. From here to here the distance is radius of the curvature. Next, imagine a straight line passing through the pole and the center of the curvature of a spherical mirror. This line is called principal axis. This is important. Any line passing through the center of curvature, if we call this center, this is P, this is radius, this line what I am showing now, this line, it is called a straight line, it is called principal axis. Principal axis. Remember that the principal axis is normal to the mirror. Principal axis is normal to the mirror. Normal to the mirror means an normal is drawn like this. This is the principal axis to its pole. Pole means this is P. Let us understand an important term related to mirrors through an activity. One activity is given. Within that activity, we will see the terms, how the mirror will work, everything now. See, one question is given. Do not look at the sun directly or even into a mirror reflecting sunlight. It may damage your eyes. In the eyes, the retina will damage. The retina is the reflection of the object as a image. In our eyes, we will see the image that will damage. So we should not see the sun directly. Hold a concave mirror in your hand and direct its reflecting surface towards the sun. You have to use concave mirror, and in front of the sun we have to use this one. Direct the light reflected by the mirror on the sheet of paper held close to the mirror. It means that one diagram I will show here. You have to use the concave mirror like this. All the radiation falls on this one, it will reflect back. It will reflect back like this through the center of curvature. All the radiations from the sun, it will reflect back through the center of curvature. Then we have to keep the sheet, any small sheet we have to keep here, means the sheet will burn or it will get the image of the sun. Move the sheet of paper back and forth gradually until you find the paper sheet bright sharp spot of light. Bright sharp spot of light we will see in the sheet. Hold the mirror and the paper in the same position for a few minutes. What do you observe? Automatically the paper begins to burn, because all the radiation of the sun taken in a particular single path or at the point, minute point, a bright sharp spot we have to get, we are getting, means there will be radiation is converted as burning process. All the radiation is turns into burn the paper. Here all the radiation converges at particular point. In the concave mirror, all the radiation of the sun converges, so we will get a sheet, in the sheet bright spot or a sharp spot. Here some of the diagram is given, concave mirror and convex mirror. We will see that one now. This is concave mirror, this is convex mirror. See the diagram. I will explain after that. I will explain the theory first. The paper head first begins to burn, producing smoke eventually, may even catch fire. Why does it burn? The light from the sun is converged at a point as a sharp bright spot by the mirror. This is very very important. All the radiation of the sun converged at a point, particular point, it is converged as a sharp bright spot by the mirror. Mirror makes that into a bright spot. In fact, this spot of light is the image of the sun. Here I have shown, explained here. All the radiation will reflect back. In fact, the spot of light is the image of the sun on the sheet of paper. In the sheet of paper, if you draw like this, all the radiation comes here, it will reflect back. If you keep the sheet here, in that point you will get a sharp point on the sheet. So this point is the focus of the concave mirror, where all the radiation falls on particular point. This is known as focus. This is very very important word, focus of a concave mirror. Between C, I will draw one diagram. This is center of curvature, this is P. All the radiations from the sun passes through the one path. It is called focus. Focus of the concave mirror. The heat produced due to the concentration of sunlight ignites the paper. After some time or some span of time, the paper will begins to burn. The distance of this image from the position of the mirror gives the approximate value of a focal length of the mirror, where the all the radiations from the sun or radiation from the light converges on the principal axis. That is known as focus. That is known as, that point is represented as focus. And the distance between P and F, it is called focal length. The P and F, it is called focal length. Let us try to understand this observation with the help of ray diagrams. Ray diagrams, two diagrams is given here. One by one I will explain. First we can go for theory part. After that I will come to the diagram. You will think in the mind, what are the things are there, what are the terms it is represented. Everything you keep in the mind. It is very very important concept. Observe the figure 9.2 closely. A number of rays parallel to the principal axis are fallen on the concave mirror. See here, so many radiations are coming. These are all the radiations falls on the concave mirror. What happens next? Falling on a concave mirror. Observe the reflected ray. All the reflected ray falls on the point F on the principal axis. This line is called principal axis. They are all meeting or intersecting at a point on the principal axis of the mirror. This point is called the principal focus of the concave mirror. This is called principal focus of a concave mirror. Similarly, observe 9.2b, this diagram. How are the rays parallel to the principal axis reflected by a convex mirror? In the convex mirror, the reflected rays appear to be come from the point on the principal axis. All the points are coming from the principal axis. The point is called the principal focus of a convex mirror. It is difference from the concave mirror. In the convex, this is the object. If you keep the object at infinity, all the radiations falls on the mirror, it will reflect back. It will reflect back. But when we bring back that lines, originally it will comes to the point F. It is called focus. P and F, the distance between P and F is called focal length. The principal focus is represented by the letter F. Everywhere in the concave mirror, also in the convex mirror also, the principal focus is represented by F. The distance between the pole and the principal focus of a spherical mirror is called focal length. It is very important. They may ask for the fill in the blanks. The distance between the pole and the principal focus of a spherical mirror is called focal length. It is very important. It is represented by the letter F. The distance between the P and F, that is called focal length or small f. This is the concave mirror. Students, you can observe here. I will show very neatly. This is the mirror, and then this point is called P, that is pole. Here the center of curvature. From here only all the circles you can draw like this. This is center of curvature, and where all the radiations from the light or a source of sun, it will reflect back in a particular point, converges in the convex, in the concave. In the concave mirror, all the radiation converges at F. This is principal focus, where all the points converge to the small spot, that is known as principal focus. From the distance of pole to the F, from the distance of pole to the F, it is represented by small letter F. It is focal length. From here to here, it is represented by small f. It is focal length. It is very important. You have learned that C is center of curvature, C is center of curvature, F is principal focus, P is pole, M and N are the mirror. Here where the incident ray is there, no, it is called incident, and the reflected ray, this is called reflected ray. And where we have to draw the normal to this one, then we will get angle of incidence is equals to angle of reflection. These are all the things you have studied in the concave mirror. Next we are moving to the convex mirror. In the convex mirror, all the radiations from the light or in source, it will comes, it will falls on here and reflect back. It will reflect back in this position. Then we will get the incident ray and reflected ray and normal ray. Normal ray, if we draw the normal, if we take back means it will comes to the center of curvature, but reflected ray will be there. No, this is reflected ray. This is reflected ray. Reflected ray, if we bring back means it will falls on particular point, that is F. All the radiation of the straight line, if we bring back means it will falls on F. This is very important. Here also it is called principal focus. From P to F the distance is focal length, and P is pole, M and N are the convex mirror, C is the center of curvature. Here the center of the curvature, it will be not outside, it looks like inside, but we feel like that, but we have to keep it in our mind. The center of curvature is not a part of mirror. This is the convex mirror. You have to draw the diagram carefully. These are all the points you have to mention here. These are all very important for your studies. Next we are moving further. The reflecting surface of a spherical mirror is by and large sphericals. These spherical mirrors is by and large spherical. It means that reflecting surfaces are the mirrors which may gives large sphericals also. Some things the reflection will be more, sometimes the reflection will be less, but converging and diverging is very important in the mirrors. The surface then has a circular outline. This is having circular outline. The diameter of the reflecting surface of spherical mirror is called its aperture. The diameter of the reflecting surfaces, it means that if this is the mirror, here one part is mirror, means from the it is R, radius, from center of curvature to pole it is called radius, but it is called diameter. It is called aperture. Very important. In the sphere the total diameter, it is called aperture. The figure 9.2 distance mn represent the aperture. We shall consider in our discussion only such spherical mirrors whose aperture is much smaller than its radius of the curvature. Here we will study about aperture. It is smaller than its radius of curvature. It is quite normal. Is there a relationship between the radius of curvature R, it is represented by R, and the focal length F of a spherical mirror? For the spherical mirror of a small aperture, the radius of curvature is found to be equal to twice the focal length. It is equal to twice the focal length, means radius is equals to twice the focal length, 2 times the small f. This is the formula. We put this as R is equals to 2f. This implies that the principal focus of spherical mirrors lies midway between the pole and the center of curvature. They are between the pole and center of curvature. That is a midway. It is represented by F. That is the principal focus. From the pole to the principal focus, it is called focal length. Here it is very important that R is equals to 2f, radius equals to 2 times the focal length. It is important, we have to keep it in our mind. Radius of curvature is equals to the twice the focal length. I hope till you understood about spherical mirrors. Now let us move further. Image formation by spherical mirrors. In the next we will study about image formation by spherical mirrors. Here the 5 steps and stages are there. All those things with explanation with diagram, it is most important. So many questions can arise through this concept, this topic. We should not lose. This is important, image formation by spherical mirrors. Thank you for listening the lesson. I hope you understood every point, every sentence I have explained without fail. If any doubts regarding this one, check once again, check this video for clarification. Next we can move for the image formation by spherical mirrors. Thank you.